People keep asking the wrong question about local AI hardware. They want to know if the newest NVIDIA card outruns a MacBook, or whether some workstation GPU can flatten Apple Silicon in a benchmark. And sure, in a narrow way, the brute force GPUs are still monsters. But that's not really the fight anymore. The fight isn't just peak teraflops, it's whether the model you actually want to run will fit, whether the system can keep feeding it without choking, and whether you can pull it off on your desk without turning the spare bedroom into a server closet. That's where Apple has quietly gotten dangerous. Apple's edge isn't that every M-series chip outguns every graphics card. It doesn't. The edge is architectural. The CPU, the GPU, the neural engine, the memory, all built around one shared pool. Apple's been beating this unified memory drum since the original M1, but local generative AI suddenly makes that decision look less like clever laptop engineering and a whole lot more like a long-term AI bet. Big language models are hungry. Context windows keep growing. Multimodal models keep getting heavier. For a lot of real local AI users, the bottleneck isn't how many theoretical operations can my card crunch. It's, can I even load the model? This is the VRAM wall. A typical gaming PC might have a powerful GPU with 8, 12, 16, even 24 gigabytes of VRAM. A flagship RTX 5090 pushes that up to 32. Incredible for gaming, rendering, plenty of AI work. But for big local LLMs, 32 gigs can still be a hard ceiling. The moment a model spills out of VRAM, performance falls off a cliff. You start offloading layers, shuffling tensors between system memory and GPU memory, waiting on data crawling across the motherboard. And suddenly, the most expensive part in the machine isn't starved for compute, it's starved for usable memory. PCs were built around modularity, usually a strength. You pick a CPU, slot in a GPU, pick your RAM, pick your storage, build exactly the rig you want. But local AI exposes the tax. The CPU has its memory. The GPU has its memory. The model has to be staged, copied, split, offloaded. PCIe 5.0 is fast, but even a full X16 connection runs around 64 gigabytes per second in one direction. Sounds enormous. Until you put it next to the memory bandwidth inside high-end Apple Silicon. M4 Max hit up to 546 gigabytes per second. M5 Max pushes up to 614. The M3 Ultra Max Studio climbs over 800. Different workloads use that bandwidth differently, but the direction is obvious. Apple is shortening the distance between the model and the processors that need it. The cleanest example is Mac Studio. Apple says the M3 Ultra version can be configured with up to 512 gigabytes of unified memory and can keep very large language models, even ones with hundreds of billions of parameters, entirely in memory. That doesn't mean it beats a rack of NVIDIA cards. It means a machine small enough to sit beside your monitor can cross a line a lot of consumer PCs can't cross cleanly. Capacity. A giant model that runs slowly but actually fits can be more useful than a faster card that can't load it without compromises. This is why the Apple versus NVIDIA debate gets messy. NVIDIA is still king of AI acceleration at scale. CUDA is still the gravity well for developers. Data centers, training clusters, high-throughput inference, multi-GPU servers, serious production AI. They all still lean heavily on NVIDIA for very good reasons. An RTX Pro 6000 Blackwell has 96 gigabytes of GDDR7, 1,792 gigabytes per second of memory bandwidth, and a 600-watt power envelope. Monster. But that's also the point. The brute force path is loud, expensive, hot, supply-constrained. Amazing when you actually need it. Overkill when you just want a powerful local assistant, a private coding model, a research sandbox, or a workstation that doesn't sound like a leaf blower. Apple isn't trying to win by being the loudest machine in the room. It's trying to make the room unnecessary. The pitch is simple. Run more intelligence locally, on a device you already understand, at power levels that make sense for a laptop or a small desktop. The new M5 generation makes that clearer. Apple is adding neural accelerators into the GPU path, pushing faster unified memory bandwidth, and openly talking about LLM prompt processing as a product metric. Which matters, because Apple is no longer selling AI as some vague feature. It's selling AI as a workload the hardware is being shaped around. There's a market reality sitting under all those specs too. High-end GPUs aren't just power-hungry. They're hard to actually buy at sane prices, because AI demand keeps pulling memory and silicon toward the data center. When the best consumer cards vanish into shortages or get marked up to nonsense, A sealed Mac with a known memory ceiling starts to look different. You may not love Apple's pricing, but at least the configuration is visible, quiet, and complete. The software story is catching up too. MLX is the key piece. It's Apple's open-source machine learning framework for Apple Silicon, built around unified memory so operations can move between CPU and GPU without the explicit memory copy pain that defines a lot of traditional GPU work. MLX-LM makes it practical to generate text and fine-tune large language models on Apple hardware. Hugging Face has a growing MLX community with pre-converted weights. Alibaba even launched Qwen models specifically for Apple's MLX architecture. That's not a small signal. The model ecosystem is starting to treat Apple Silicon as a real local AI target, not just a weird side path. Core ML and the Foundation Models framework push the same idea from the app side. Apple wants developers building intelligence into normal apps without shipping every private request off to some remote API. The on-device model inside Apple Intelligence isn't trying to replace frontier cloud models. It's trying to make small, useful private inference available everywhere. Health apps, writing tools, video editors, education apps, task managers, eventually personal agents. When Apple tells developers they can use on-device AI for free, offline, with privacy protection, that's a different kind of platform play. It turns local inference from a hobbyist workflow into a distribution channel. The privacy angle isn't just marketing copy. The more personal an AI assistant gets, the more dangerous the cloud default becomes. A real personal agent needs your messages, your files, your calendar, your habits, your photos, your tasks, your location. That's exactly the data people do not want sprayed through random APIs. Apple's answer is local first, with private cloud compute for requests that need a bigger model. You can be skeptical of the execution, and honestly, you should be. But the strategic direction is clear. The device becomes the trust boundary. The hardware gets designed so more of the work happens inside that boundary. There are still real limits here. Apple Silicon isn't the answer for everyone. If you need CUDA, if you're running Linux GPU servers, training very large models, serving hundreds of users, or chasing maximum tokens per second per dollar in a rack, NVIDIA is still the obvious pick. Apple also charges heavily for memory upgrades, and unified memory can't be upgraded later. A Mac with 128 or 512 gigabytes is not cheap, and because that memory is shared, you don't get the same dedicated GDDR-only behavior you'd get from a discrete GPU. The honest version of this story isn't Apple killed NVIDIA, it's Apple found a different battlefield. That battlefield is local personal intelligence. It's the creator running a 70B model next to Final Cut, the developer testing agent workflows without shipping private code to a cloud service, the researcher loading a bigger model because capacity matters more than some synthetic benchmark, the small business owner running offline AI tools without an infrastructure team behind them. In that world, silence matters, power draw matters, desk space matters, being able to keep the whole model in memory matters. The machine that wins isn't always the one with the biggest spec sheet, it's the one that removes the most friction. So the local AI hardware war isn't ending, it's splitting. NVIDIA owns the factory. Apple is making a serious play for the desk, the backpack, the private workspace. That's why unified memory suddenly matters. It turns the Mac from a polished creative machine into a local AI appliance hiding in plain sight. The old PC logic said modular power would always win. The new AI logic says memory shape, bandwidth, software integration, and privacy may matter just as much. And if the next generation of AI agents ends up living closer to the user than the cloud, Apple's quiet little architecture bet may turn out to be one of the most important hardware decisions in modern computing. Stay sharp. Jane Sterling, Sterling Intelligence.